So for today, our lesson is 11.2, probability with two-way frequency tables. So this kind of goes with what we were doing on Monday with the two-way frequency tables. We're just going to add a probability from the tables. So for prior knowledge here, it says the table shows how 20 students get to school. We have, we kind of saw this Monday. We have 8 students take the bus. We have 7 students take a car. 5 students walk to school. So we have a total of 20 people. So the question here says, what percent of the students take the bus to school? So take the bus to school. So for probability, you take the number of outcomes over the total. So how many students take the bus is what we're asking for. So take the bus is our number of outcomes. So how many students take the bus? The bus? 8. 8 students take the bus. So for my probability, it's going to be 8 over, what's my total amount of students? 20. So then we get that in the calculator. 8 divided by 20. 8 divided by 20. Oh, what is it? 0.4. Okay, but it's asking for percent. So a percent, if you remember, you have to move the decimal over 2 times. So 1, 2. That means this would actually be 40%. Okay. So again, percent, you move the decimal over 2 times, and that becomes your percent. All right. And so today's lesson, we're going to be looking at percent and probability. So for concept here, it says the probability of an event is how likely an event will occur, and probability can be expressed as a fraction, a decimal, or a percent. So the table shows how 20 students get to school. So we see the same table, and it says a student is chosen at random. What's the probability that the student walks to school? So then we can see that the probability is students who walk over the total students. So it would be 5 students walk to school for a total of 20 students. So 5 over 20 gives us a 0.2, which is 20%. So notice I have a fraction, I have a decimal, and I have a percent. So all 3 of these fractions, we have decimal, and then we also have a percent. So our probability can be expressed in all 3, a fraction, decimal, and a percent. Okay. So then the question here says, if a student is chosen at random, is it more likely that the student will take a car or a bus to school? You're supposed to explain. So looking at the data, it's asking specifically for a car or a bus. So looking at students taking a car, that's 7 out of 20, or taking the bus would be 8 out of 20. So which of them are more likely to, what do you guys think? Is it more likely to take a car to school or to take the bus to school? The bus, right? So we would say it's more likely, because we're looking at these two, it's more likely the student will take the bus and I'd say because there are more students who take the bus. Because more students take the bus than a car. Okay, so now we're gonna look at probability from a table. So from a table here, it says we have the two-way frequency table, shows the number of boys and girls in each grade level at a high school. So I could see the boys. There's a total of 396 boys. For girls, we have 412. And then it says the student is chosen at random to the nearest percent. What is the probability that the student is a freshman boy? So then for this one, we would try to see the number of freshman boys. So remember, you always want to do the probability is going to be the number of outcomes. So number of desired outcome divided by the total. Okay. So in this case, what's my desired outcome? What specifically are they asking for? The freshman boys. So how many total freshman boys do we have? 98 over, what's my total amount of students? 808. Good. This is the total, is 808. So we would divide 98 divided by 808, and you're going to get a decimal answer. Can you guys give me like the 3 decimal places? 1 to 1, okay. And then the direction here says to give the answer to the nearest percent though. So nearest percent is your move the decimal twice and you're gonna round to just like the percent, whole number. So move the decimal twice. So looking at the 1, the 2 stays. So then it's approximately 12%. You're moving the decimal twice because it's asking for percent. Okay, the second question says a student is chosen at random. What's the probability that the student is a senior girl to the nearest percent? So now we're looking at senior girls. So senior girls is 108. Yes?
For when you do the percentage, would it matter if, like, say, the 1 was 5?
Yeah, if it was a 5, then it'd be 13%. Yeah. Okay, so in this one, we're asked for the probability for senior girls. So this one is going to be number of senior girls divided by total students. And you guys don't have to write that beginning part, but I'm just writing it out so you can see how we're getting the answer. So what is the total number of senior girls? 108 divided by the total 808. So you would go put that in a decimal, and you're going to go 3 decimal places. Can you tell me what it is in 3 decimal places? What is it? 133. Okay. So to the nearest percent, move the decimal twice. So 1, 2. So after the decimal now is a 3. That's less than 5. So it's going to stay as 13%. Okay. Let's look now. Did anybody need that still? Sorry. Are you guys okay with that now? Okay. This one, now we have still a table, but now we're still looking at the we still have the same data here. Two-way frequency table, number of boys and girls in each grade level. This time, now the question is, a sophomore is chosen at random. A sophomore is chosen at random. And so now to the nearest percent, what's the probability the student is a girl? Okay. So this one is this one's called a conditional statement. So I kind of added here, this is a conditional statement. Because it's asking for what's the probability it's a girl given I have already chosen a sophomore, okay? I am specifically only picking the sophomores. And so in this case, for my probability, I'm actually going to be getting for the total sophomores. Okay, so again, this time I am looking at the total sophomores for the denominator because I'm telling you a sophomore is chosen at random. Thank you. So from the sophomores, what's the probability of getting a student that is a girl? Okay, so in this case, I have my sophomores. The total is 210, but out of the sophomores, how many of them are girls, basically? Okay, so a student that's a girl, given it's a sophomore. Okay, so in this case, I would get the sophomore girls in the numerator. Okay, so in this case, the number of sophomore girls is 106 over, this time I don't divide by 808, this time I'm dividing by 210, because specifically they're choosing a sophomore. Okay, so can you guys do 106 divided by 210 for me? And 3 decimal places. 0.504. Thank you. And so if we then move our decimal over 2 times, that's a 0.4, so that's less than 5. So then we would say it's approximately 50%. So there's a 50% chance, approximately 50% chance of choosing a girl, given we've already chosen a sophomore. Okay. The second question here says, a boy is chosen at random. So I'm telling you, I am picking from the boys, okay? I'm not going to ask any female students. So for my probability, I'm going to divide by the total boys. Because I'm only going to choose a boy. I'm not going to ask the girls, okay? So because I'm only focusing on the boys, what's the probability that the student is a junior to the nearest percent? So this time I'm looking at the boys. What's the probability that the student is a junior? So for my numerator here, this is going to be the number of junior boys. So how many juniors are boys? 100 over, what's my total for boys? 396. And you guys are going to divide that to the, 3 decimal places. What would that be? 100 divided by 396. Thank you, 0.252. So it's to the nearest percent. Move the decimal twice. So the 0.2 keeps it at 25%. So approximately 25% of the boys are juniors. Okay, now for the third question here, it says a girl is chosen at random. To the nearest percent, what's the probability that the student is at least a junior? So this one's a little bit different because of the word at least. So at least a junior, what does that mean? Talk to your partner. What do you guys think? At least a junior. What is that asking for? Lefties, if you're sitting on the left side, share first, please. Okay, so what does at least a junior mean? What does at least mean? Yes? Juniors and seniors. So at least that's like a minimum. The minimum is being a junior. So it could either be a junior or a senior. Junior or higher, right? And then what group of students are we focused on in this example? We're focusing on the girls, right? A girl is chosen at random. So this time I'm looking at the girl population. And to be at least a junior would be the juniors or seniors. So 96 plus the 108, okay? So this is going to be the probability of the number of girls that are juniors or higher. That's what the at least means, is anything higher than a junior. And then we're focusing on the girls. So this is going to be total for girls. So in this case, I would do the 96 plus the 108 over, what's my total for girls? 412. So you're going to do 96 plus 108 and then divide by 412. And then to 3 decimal places, what do you get? $96 plus 108 divided by 412. 0.495. Okay. This time, when you move the decimal twice, notice I have a 5 this time. That's 5 or more, so we have to round up this time. So this is approximately 50%. So approximately 50% of the girls are either juniors or seniors.